do today.
I mean, he's the teacher. He can do what he wants.
Yeah, but I mean, he assigned it like with not even 25%.
He also wanted it to be double spaced, so you're really just writing one name.
Damn.
Yeah.
Still
I'll give you 100 no matter what.
Sticker, sticker. Easy.
Still.
I wouldn't want to do it, but
Oh,
I
that's
All you
your
gotta do is
uniform.
summarize your disability and then write about how it does stuff.
see,
Yeah.
great.
Just Dylan or everybody has a disability for that?
Yeah, everyone.
Yeah.
I don't even know what disability is except for not being or not on that or.
Do you guys see what we're doing today? You're
I don't want
Honestly though, this is still easier than my science math is, so.
Oh, good. Yeah, we are graphing today. Gosh. Always comes back around.
That's the only thing I hate about my science and my math being right by each other is this year it's two math pretty much classes.
Okay,
At least
So,
I like that.
let's just write down how we even graph. So there's 3 different forms and 3 different ways to graph. What is one form of a quadratic?
Quadratic.
A what?
Quadratic.
That is it. What was the question you asked?
We have 3 different forms of a quadratic. I want one.
General,
General form.
intercept, and standard.
Yeah, there we go. Standard, intercept. To remember what these look like. So we know the names of them, which is good. So now what is general form, what is standard form, what is intercept form?
General form is y equals ax squared plus bx plus c. And standard form is y equals a parentheses x minus a to the power plus k.
Well, I got 2 out of the 3, found them.
And then intercept is y equals a parentheses x minus p parentheses x minus q.
Awesome. Okay, so here's our 3 forms. When we took our test and learned about graphing, we had all 3 forms that we had to graph. What is the main thing that we need to find in a quadratic graph? What's the main thing we have to find?
Your vertex.
Or
The
your
vertex. Okay. So how do I find the vertex when it's in general form?
It's negative b over 2a.
Yeah. So to find the x value of the vertex in this form, negative b over 2a. Then you have to substitute that number in to actually find y. Okay. So that's general form. What about standard form? How do I find vertex? Go for it.
H. K.
Yeah. So in standard form, it's nice because the vertex is literally right in the problem. You just need to pull out the correct numbers, and you always change that h value to positive. Okay. What about intercept form?
It's p and q, isn't it?
So Rain had it. It's the midpoint. Or actually, let me.
Oh, is this where you find the c equals?
Sorry, let me squeeze that in there. So yeah, x equals the midpoint of p and q. So what does p and q actually represent?
X or is it the y?
Mm-hmm.
Points on the
Yeah, they're the x-intercepts. So yeah, they're points of the graph. So basically, once you plot the x-intercepts and halfway between them, that's the x value of the vertex. And then same thing, plug in the x value, find y. So you're gonna see graphs of all three of these forms, and you have to graph the parabola. So you have to remember how to find the vertex. And then finding other points, you're just plotting points for it. So we can all plot points, make a table on all the things, but vertex is what you need to find first before you can actually plot points. Okay. So we have quadratic inequality with two variables. So today we're doing two variables. Tomorrow we're going to do one variable.
And one variable.
It's kind of opposite.
Oh, yeah. What?
I said so it's one harder.
They're just different. Two variables means we're graphing a parabola. One would mean that we are like solving it. Like solving the equation for x. Okay, so basically, what does an inequality mean before we analyze what this graph is going to look like and how it's different than an equation? Inequality are specific symbols.
The line, right?
What do you mean the lines?
Parentheses. I guess the things in the parentheses.
So basically, we don't have a quadratic equation anymore, so we don't have an equal sign. We have a different symbol.
Greater than.
Yeah, so all those less than, greater than, less than equal to, greater than equal to. And we worked with inequalities before when we were doing linear graphs. Does anybody know how the graph of a line changed when we were given an inequality? You had to add two pieces.
Flip this one.
Less than and greater than represented one thing. Greater than or equal to less than represented one thing. If you're thinking if you multiply or divide by a negative, this kind of flips. Yeah, that's one thing that adds with inequalities. Yeah, so if we're on a number line, we have like a filled in dot, which represented less than or equal to or greater than equal to. Or if it was less than or greater than, then it was an open circle. So that's if it's a number line, you have a circle and a dot. But we're actually graphing this parabola, that's the U. So not necessarily like a circle and a dot. What did you say? Yeah, we have a dashed line. And then less than or equal to greater than equal to solid line. Yeah, so before you connect all your points to your parabola, you should make sure, is it a dashed line or a solid line as you go through it. So that's one thing that you have to add to your parabola graph. Does anybody know what the second thing is?
When you forget to make it dash and you
When you cry, you just erase a little bit.
It's fine too.
Yeah. Valence puts like dashes in it. Because he doesn't in pen.
Why are
When you forget how to do a dash, forget to do the dash line, like that.
Yeah, so then I just crop. It's yeah.
Okay. Second part that we have to do is shading, which I don't think anybody liked the last time we did shading.
It wasn't that bad.
It honestly wasn't that bad.
So you have to test a point not on the parabola. So most of the times we pick the point 0, 0 because that's the easiest point to do. Unless 0, 0 is on your parabola, then you can't use that point. We have to test the point, figure out, is this creating a true statement or a false statement? And we always shade on the true statement. So either we're inside the parabola or outside the parabola. Alright. So now that we have all the information, we're going to do 3 examples.
Already.
Nice.
Ooh. What should we find first?
Your vertex.
Vertex. How do I find the vertex when it's in this one?
that's general, so just x equals negative b divided by 2.
Right? General form, so negative b over 2a. So in our case, what is the b value? Thank you. And the a value is
No positive one.
negative 1.
Switch it, don't you?
Because there's that hole in there. Okay, so negative 4 is just positive 4. And 2 times negative 1 is negative 2, so this divides to be what number?
Negative 2.
Negative 2. Okay, so we have the x value of the vertex. We're going to use this to find the y value. So plugging it in. Then you can use less than if you want to. I just wrote an equal sign. So I have negative 2 squared minus 4 times negative 2 plus 1. So replace the x's with negative 2, which is what I found. So following an order of operations, what should we do first? Okay. So what's negative 4 times negative 2?
Positive 8 plus 1. And then that's 2 positive, which squared is 4. And then equals 13.
So you do exponents first, so it's the quantity negative 2 squared, which is positive 4. And then the negative, oh gosh, and I wrote a 2.
So it's actually negative 4?
Yeah.
So it would actually be what?
Right, because you do it in the parentheses and then you have
Yeah.
brackets on it.
Oh, wait, no, that's 5.
Yeah. So basically my vertex is order pair, negative 2, comma 5. Bam.
Okay, 5 over.
Okay, so I'm just going to graph that point first before I do anything else. And then I get this question asked a lot, so since it's less than, they're like, when I create the point, do I have to have an open circle? You don't need to, just plot the point, because we're going to have a dash line for this. So, if you want to do the open circle, I won't mark you wrong, but it's unnecessary. Okay, I could even draw my axis of symmetry if I wanted to. So since I have my vertex, I can now pick 2 points to plot and then reflect them over. So what 2 points would you like to substitute in? Or graph? Nobody all jump at once.
Negative 1. And 0.
I like those numbers. Okay, so let's plug in negative 1. So my equals negative 1 squared plus 4 times negative 1 plus 1. Order of operations.
So the first one is 4.
Perfect. And then I can reflect that over.
And the second one is 1.
Show. And reflecting it over. Right there. Okay, so now I have 5 points for my parabola. So since it was less than is telling me it's a dash line. So boop. So something like that. So there's my problem with the dashed line. Looks kind of weird. So the last thing that I have to do with inequality is figure out, am I shading inside the parabola or outside the parabola?
You can point.
So what point are you going to use?
Negative 2, 0. Just because it's inside.
Yeah, you can.
Oh, I guess you can still do 0, 0.
Yeah, 0, 0 is still inside. Just barely though. But it still works.
I can't tell them that what I'm not.
Yeah. Okay, so if we plug in 0, we have 0 less than negative 0 squared minus 4 times 0 plus 1. So what does the right side simplify to be?
0. Oh, the right side.
Okay.
1.
1. Yeah, first two terms cancel, you just have that one.
So you can shade the inside because it's.
Yeah, so this is a true statement. So everything inside is true, everything outside is false. So we're shading inside the parabola. Beautiful. Wasn't that great fun? Or like refreshes the memory. Now we do parabolas. Okay. Next one. So the story problem isn't really like necessary that you have to write everything down. You just have to graph the inequality. And our inequality is w less than or equal to 250 x squared. So computer desk with a solid glass top can be safely support a weight with that, where x is the thickness of the desktop. Yeah, interesting.
Can you get 215 x squared minus themselves, like separate things?
What do you mean?
They're McDonald's, right?
Yeah, we still want to graph, so is this in general form, standard form, or intercept form?
This. I may say general.
Yeah, I'd probably say general. We just don't have that bx and c term, which is totally fine.
Would you just make them 1 or 0?
Yeah. So vertex, we're still using that formula negative b over 2a. So in our case, we don't have a b value because we don't have an x term. So the b is just 0. And then a is at 250, which seems crazy, but 0 divided by any number, doesn't matter what it is, it's just 0. So then I can plug that in to find the y. And what is the y value? 0. So my vertex, 0, 0. Nothing crazy there. Technically, since it is a story problem, we should be in just like the first quadrant for just positive values. So the thickness has to be positive, the weight in pounds has to be positive. We don't have negative weight or negative thickness. So I'm just going to graph the first quadrant. You could graph both if you or all four, but you don't need to. So 0, 0, starting value. Okay, so now making a table. What do you want to substitute in for x?
1.
1. And what do we get out? 250. And plug in 2. 1,000. So my y-axis is increasing by a lot. I'm just going to count by 250s. That seems good enough. So at 1 x-axis still counting by 1s because we're not going up by very much here. Okay. So I mean, this is like 1/2 of the parabola. Technically, I reflect those over, but I don't need the second quadrant. So I can connect these 3 points together. Is this a solid line or a dashed line before I actually do anything?
Solid.
Solid, because it's equal to. So here's my parabola. Now I just need to figure out, am I shading like kind of like above the parabola towards the y-axis or below towards the x-axis?
Can we do 0, 2?
Okay. Yeah, we can't use 0, 0 because that's our vertex. 0, 2 is doable. So this is 2 less than or equal to 250 times 0 squared.
Two is
No.
not less than or equal to 0.
The
So you have to shade on E.
Right? 0, 2 is like right there. That's false. So the other side is true. So technically it's below it, which is kind of weird. I mean, they keep going to the right forever. I'm not shading below the x-axis because I can't have that negative weight. So I'm just staying above it.
Oh.
Yep, if you go below it, it's not. a big
No, I
deal.
just accidentally shaved the wrong hand.
Oops.
I wrote it in the
So you can't go past the parallel, you just go under it.
Yeah, I mean, my parabola would keep going forever and ever, which means it's going forever to the right. So I could shade more to the right, but
Right. Okay.
I don't want to be excessive here. Last one. Graph the system. So I have 2 parabolas in one graph. It's going to be beautiful. We did this with lines before. We had to graph multiple lines in one thing and then shade the region where they overlapped.
Oh, and you have to line them up, right?
The first one, okay, but one's the standard one and
So standard form. Yeah, so since we have each form, we can figure out the vertex. I'm actually going to color code this. So it'll make- Okay, so let's work in standard form first. So the vertex. No, the vertex is filling.
Negative.
It would be
HP.
-1, -3.
yeah, negative one. No.
1,
After you
-3.
change it, Yeah.
Yeah.
Positive one.
Sorry.
positive.
Yep, so we're just picking up the numbers. Whenever it's inside parentheses, you always have to switch the sign to positive 1 and -3.
Yep.
Also, what about the vertex for my intercept form?
It's your midpoint of P and Q. So -2.
Positive 2. Right, so the x-intercepts would be 1 and 3. And then in between 1 and 3 is 2. And then we can use that to find the y value. So -2 times 2 minus 1 times 2 minus 3. Okay,
2 minus 1 is 1, 2 minus 3 is -1, 1 times -1 is 1, negative 2 is
positive 2.
positive 2. Yep. Yeah, I have
Okay, so the vertex is 2, 2. Great. Okay. I'm just going to draw my graph here on the right side. Okay. Sorry, I had to get my graph all together here. So I'm going to plot my vertex, 1, -3. So we can make a table for my graph in standard form, my problem in standard form. Any thoughts on what x values you want to plug in?
I'm sorry, what one did you graph?
We're doing standard form first, the first one. So I
Okay.
just plotted my vertex, 1, -3.
Oh, okay.
Now I want to do a table, so plot some bullet points to finish it. So x values, we plug in. Dylan, what x values do I plug in?
-1, 0.
Okay. So if I do -1 first, plug it into the equation. Order of operations. -1 minus 1 is
1, I mean 2, -2, times 2 would be 4, minus 3 is 1.
okay. Do the same thing, plugging in 0.
0, 0 minus 1 is 0 times 2 is 0 minus -3.
0 minus 1 was -1.
Well, -1 times
-1.
would be 1 minus 3 is
Alright, so 0, -2. And then I didn't draw my axis of symmetry because I didn't want my graph to be messy. I'm kind of weird like that, so reflected over the vertex. Put over there. Same thing, -1, 1. Reflected over to there. And then before I connect all 5 line points, is this a dashed line or a solid line?
Dash.
Okay. Okay. Let's just finish it. So, where's the shaded region in this case? So, what point do you want to test for the shaded region? Brain, what point do you want to test for the shaded region?
4?
What would be the easiest point to test?
1?
Okay. So basically we're testing that point right there. Okay, so plugging it into this lovely thing, we have 1 greater than 0 minus 1 squared minus 3, I think it was. And we need to simplify this. So 0 minus 1 is
-1,
squared is 1 minus 3.
-2.
-2. So is 1 greater than -2?
Yes.
True.
So we shade inside there.
Yeah, and I'm not going to shade yet because we want to shade the overlapping part. So remember with lines we did this arrow thing? That rings a bell.
Yeah.
So I know, just to remember, I'm in the shaded spot.
Why can't we just so you remember it, and then you can shade it here.
Shade it when we get the other one grabbed in it.
Okay.
Okay. So the intercept form, when we have the vertex, which I'm going to plot right there. And same thing, we need to make a table. But technically, I do have some other points. I have the x-intercepts, which I'm going to plot. So x-intercept of 1 and an x-intercept of 3. And I just need to plug in 1 more point to graph. So what x value do you want to plug in?
-1.
Okay. So then you have like y equals -2, -1 minus 1, -1 minus 3.
So we have the -1 minus -1 is that's 2. -2, and then you have -4.
Okay.
And -2 to -4 equals 8, and -16.
Ooh. Okay, so that would be down there. I'm just gonna make a point right there.
I'm so sorry.
No, that's fine. I'm not gonna change 90 by 2s now. It's too late. I'm too far in. So solid or dash line?
It would be a solid line.
Solid. So, oh gosh, kind of left my point.
See what I mean? I just made the last one, so I forgot.
Yeah. Okay, but we should check where we're shading to finish this problem. So what point are we going to test? Okay. Yeah, 2, 0 would be right there, which is inside. That'll work. I have too much writing down. And it's 2 minus 1 and 2 minus 3. Wait. So simplify this.
1 and -1. That would be 2.
2. So is that true or false?
It is true.
Yep, 0 is less than 2.
So you'll be shading between them.
Yes, we're inside this pink one. So where they overlap is right there. That little crevice.
Yeah.
Okay.
Next.
Well, that was our third problem, so we're done. Woo.
Oh.
Okay. Goodbye. Goodbye, sir.
Actually, I'm gonna fix this.
Okay.